Assalamu alaikum everyone. The next data structure we are going to study in the course is stacks. Probably you will have encountered it in programming 2 course, but we're going to study it from the scratch actually, so we don't assume any knowledge of stack. This is the outline. First we will look at what is the definition of stack, and then we look at the implementation. Now in the implementation we're going to look at 2 approaches. One is implementation using array list and implementation using linked list is the other one. Okay, then we will look at a stack that actually came in the Java library, but which actually is not a very good stack. We will explain that when we come to that topic. Then we spend the rest of the lecture looking at examples, applications of stack. Okay, first we look at basic direct examples, and then we will look at more example of stack application, especially with respect to a type of expression called postfix expression. Okay, we will look at 2 algorithms that employ stack. One is postfix conversion and the other one is postfix evaluation. So this is our agenda for this lecture. Let us start with the definition. What is a stack? A stack is a linear data structure, just like linked list is a linear data structure, that can be accessed only from one of its 2 ends for both storing and retrieving data. So this is the difference. Whereas linked list allows you to add and remove from anywhere, in stack you can only add and remove from one side only. Okay, so for example, if you have a stack of books or stack of disks, you see that you cannot add a book at the bottom here, unless if you have to lift all the books, which may be too heavy for you. In this case, you cannot even do that actually, because the other side is blocked. You can only add elements at the top and remove them from the top. Okay, you can think of many other examples. For example, a stack of plates in a restaurant, and so on. Okay, so because of this nature of stack, you can see that the last element you will put is the last one you can possibly remove. Okay, and therefore stack is said to exhibit what is called LIFO. So stack is a LIFO structure. LIFO means last in, first out, as I have written here. Okay, because one side is blocked, you can only put from one side at the top, and therefore the last element you put is the last one that you can remove. Okay, so this is the idea of stack. What are the operations of stack? These are the main operations. First of all, you should be able to add an element at the top of the stack. Now this is called pushing an element at the top. In terms of stack terminology, adding an element has a technical word called push. So to push an element means to put an element in the stack, and we know we can only put an element at the top, not in the middle, not at the end, only at the top. Okay, the other operation is pop. So pop will remove the topmost element from the stack. Then we have top element. So top element is similar to pop, except that it doesn't remove. It only returns the topmost element in the stack without removing it. Okay, These are the three principal operations of stack: push, pop, and top element. But we can also have clear to completely empty the stack, and it's empty to check whether the stack is empty or not. Okay, this figure shows the operations of stack. So suppose you start with an empty stack. This figure is from the book actually, figure 4.1. If you now push 10, 10 will be the only element at the very bottom of the stack. If you push 5, 5 is going to be at the top of 10. So there is no way you can remove 10 now without removing 5. Okay, therefore if you say pop, pop will actually remove the 5 and you will be left with 10. Now if you push 15, again 15 will be at the top of 10. Push 7, 7 will be at the top of 15. And if you now pop, it is the last one that came in, which is 7, that you will remove. So you will be left with 10 and 15 in the stack. This is basically how stack operates. Now let's look at the implementation. As I said, we're going to look at two ways to implement a stack. First using array list, and then later on using linked list. Okay, so using array list means unlike what we did in the case of linked lists, we're not going to implement stack from scratch, from nothing. Yani. Okay, we're going to use array list as the underlying data structure to actually store the elements, so that we only provide methods of stack in the context of that array list. So as you can see here, the first thing we did is we declare a variable of type array list called pool, and we have in fact initialized it with an empty array list. Okay, of course before you can use array list you have to import it. So the idea is we have an array list. Okay, as you can see it's private, so from outside this class you cannot access this variable, and therefore you cannot access the other methods of array list for this variable, unless those for which we provide public methods to access. This is the idea. So what we're going to try to do, as shown in this figure, try and block one side of our array list so that we can only add and remove from the other side. In fact, we're going to block the beginning side and allow the end side to be open, so we can only add at the end and also remove at the end, as you can see in this figure. Constructors, here we have two constructors. The default one will do nothing because the array list has already been created. Java in this case will give the default size. Okay, but we can also allow the user to specify the size, because as you remember, with array list, if you don't specify a size, then Java will give a default size. When that size is exhausted, the array list will be doubled, and the data has to be copied from the smaller size to the bigger one. So if the user knows, how many elements you're going to store in his stack, we're going to allow him an opportunity to actually create an array list of that size. Okay, so that's why we are allowing the integer n here to be received, and we will then use the ensure capacity method. I'm sure you remember this method. This will make sure that the array list that has been created here will be immediately expanded. Well, not expanded actually, but another one will be created to be of this size. Okay, so that there is no need for repeatedly copying from smaller one to bigger one, and then when that finished, create another bigger one and copy the data. This will waste time, but this one will ensure right now if the user say 1000, we will immediately create an array list of 1000 elements. What about the methods? The first is add, or push as we call it. How do we push an element? We're going to push an element at the end of the list. And if you remember the methods of array list, there is add method, which will actually add at the end. So that is the appropriate one to use to implement the push. So we have public void push. It will receive an element, but to add the element to the array list, all we have to say is pull.add element. Okay, the add will automatically add at the end of the list. Now, what about pop? Here we have a problem actually, because if you recall, well, we need to remove this element. The last one that came in is the one we want to remove. Unfortunately, there is no remove last in array list. There is remove last in linked list, but there isn't one in array list. In fact, these are the remove methods available in array list, if you recall. This is from the lecture on the second lecture on W linked list. Towards the end, we listed the method of array list, and there are only two remove methods. One remove will take an object and remove it. Obviously, we don't need that because we're not going to allow an element to be removed arbitrarily. Only the last element should be removed. So it means this is the one we need, remove at a given position. But the question is, what is the position of the last element? Okay, what is the index of the last element? Well, the good news is there is a method size. Okay, if you call size, pull.size will tell you how many elements are in the list. And therefore, to know the index of the last one, just subtract 1. Okay, because for example, here we have 1, 2, 3, 4, 5, 6, 7 elements. So size will tell you there are 7 elements. But the index of 9 is actually 6, because the counting starts from, the indexing starts from 0. So this is 0, 1, 2, 3, 4, 5, and 6. Okay, so that's how we're gonna implement the pop, by calling remove at size -1, as you can see here. So to implement the pop, we say return pull.remove pull.size -1. Of course, we need to be careful. The array list could be empty, so it's good therefore before we just return the value to check if it's empty. I will show you this empty method in the next slide. So if the stack is empty, throw an exception, or if you want to make it easy for yourself, you can just say return null. Okay, but this is the implementation from the book. It is throwing empty stack exception. Okay, I hope the pop method is clear. Next is the top element method. So again, top element, we want to return this last element, but without removing it. Okay, the appropriate method to use is get, therefore, not remove, because remove will definitely delete the element. Okay, so but again, we have to give the get method the index of that element, and the index of that element is pull.size -1. Okay, so this is how you implement the top element. Again, you have to make sure the list is not empty. The stack is not empty. If it is empty, you throw an exception. Okay, otherwise return pull.get pull.size -1. Okay, now these are the other remaining method. Clear. To clear the stack, just clear the pull, clear the array list. And similarly, to check for stack is empty, just call pull.isEmpty, because array list has its empty method, so just call it. So toString Again, array list has a toString. So just say pull.toString. It will return to you all these elements in the array list, but as one string. Okay, so that is the implementation of stack using array list. So if you understand, we are basically relying on the method of array list. Let's look at the linked list implementation. So linked list implementation is even easier actually, because linked list has more methods than array list. For example, it has remove last, it has get last, so it will make some of the method easier actually to implement. Okay, so as we did with the array list, we need to import the linked list and create an object of linked list within the LL stack. So the name of our stack is called LL stack. Okay, create a linked list, an empty one in this case. Okay, the same type for the stack. Okay, so this is generic stack actually. It will create a generic object of linked list based on the type. Okay, here there is no need for a constructor that accepts a size, because as we know, size is not an issue with a linked list. Okay, so we only have the default constructor. Okay, in terms of push, no change compared to the array list implementation. We just need to call the add method. Okay, because add will always add at the end, both for the array list and for linked list. So add will add at the end. Just say list.add. Okay, what about pop? Now this is going to be much easier, because as I said, we want to remove this last element, and luckily linked list has remove last. So that is the method we should call, list.removeLast. No need to say get the size and then subtract one and then remove the one at that particular index. Just say list.removeLast. It will remove the element. But again, you have to take care of the situation where the stack could be empty. Okay, what about top element? Again, there is a good news, because there is get last. Okay, so we don't need to give any index. Just say list.getLast. Okay, if the list is empty, we throw an exception. Otherwise, return list.getLast. Okay, the other methods are straightforward. Clear, just call the clear method of the linked list. Is empty, just call the isEmpty method of linked list. And toString, just call the toString method of the linked list. So these are the two implementations of stack, using array list and using linked list, the Java's linked list. In the lab, we're going to ask you to implement a stack using our doubly linked list. So you can imagine, therefore, you will be calling our own methods, not the Java's linked list method. What I mean is, for example, we don't have a method called add, but we do have a method add to 10. So when you come to implement push, you will call the add to 10 method. Okay, of course, here when you are creating your list, you will create a DLL object. Okay, DLL of type T list equal to new DLL. When you come to remove the last element, you will have to use the method available in your DLL. We don't have remove last, but we do have remove from tail. Okay, so very similar method you need to call to implement our own stack. Okay, using our own doubly linked list. Now let's look at the comparison. How does array list implementation of linked list compares with linked list implementation in terms of efficiency? It's basically the same comparison between linked list and array. Okay, let's go through the points. Say, how does the array list implementation of stack compares with the linked list implementation? Okay, we know that array list implementation uses a flexible array and therefore it has two potential disadvantages. Okay, one of them is waste of memory. Why? Because when creating the array, size has to be specified either by you or by the Java system. Either way, that size remain allocated throughout the execution, whether you use all of it or not. So if the size allocated is too big for the problem you are solving, definitely you are wasting memory. Okay. The other potential disadvantage is waste of time. Why? Because when the array becomes full, a new larger one has to be created and data must be copied from the old small one to the new bigger one. So these are the potential problems which do not exist in linked list. Okay, it says the linked list implementation allocates exactly what is required, and therefore it avoids the above two disadvantages. This figure from the book actually shows these two disadvantages. You see, for array lists, a size has to be specified. So you have to create an array of a certain size. Okay, now if you notice here, after the operations that are executed here, we never use more than 3 cells out of these 5 cells that are allocated. And therefore, at least 2 cells are wasted in this case. Okay, you can think of a similar issue in case we attempt to add more than 5 elements. So another array has to be created of size double the size, so size 10, and data has to be copied from the smaller array to the new one, so that will also waste time. Whereas this figure for the linked list shows there is no such problem, because in linked list we only create the nodes that we need at any given time. So when you say push 10, a node will be created containing 10. Push 5, a node will be created containing 5, so now we have 2 nodes. Pop, so this node will be deleted and we are back with only 1 node. So there is no waste of memory at any one time, and there is no need to copy data from one linked list to another linked list. So again, no waste of time. So this is basically the comparison. This figure is from the book, figure 4.6. It shows you the relationship between implementing a stack using array list and also using linked list. The Java library actually comes with a stack. You can find it inside the java.util package. And these are some of the methods of the stack in the Java library. It has push and pop as usual. It also has a method called pick. Now pick is equivalent to top element, because it's going to just check and see which element is at the top and return it. You can see the return type is object, but without removing it. Okay, it has this empty, it has search, and then this is the constructor. So this looks like a normal stack, but actually it is not a stack. Unfortunately, the way they implemented it make it to be not a stack. Why? Because this stack class actually is derived from the vector class. When we say derived, means it extends the vector class. So they said stack extends vector. And as we know, when a subclass extends a superclass, it automatically inherits all the methods of the superclass. Therefore, this Java stack, actually these are not the only methods. It has all the methods of the vector class as well, which means Not only can you remove at the end, you can also remove at the beginning. Okay, because there is remove with an index. You can give an index, it will be able to remove from anywhere. Okay, similarly for the add, you can add anywhere. And therefore, this stack in the Java library actually is not good. This is what the book says regarding this class. So the Java implementation of stack is potentially fatal or deadly because it is really not a stack, but simply a structure with stack related methods. Okay, so you are advised not to use this stack. If you have a real project to implement that requires a stack, it's better you use your own stack, but not the one in the Java library, because really it's not a stack. It has a potential security issue. Since stack is supposed to allow a removal and adding only at one side, and this one is not allowing that. I mean, it's allowing more than that. It is not a stack. Okay, so this is the point to note. Okay, so that's the implementation of stack and comparison. Now we're going to focus on examples of its application. How do we use stack in our programming problems? Okay, so here it says generally stack is very useful whenever data is to be stored and retrieved in reverse order. And there are many situations that involve that scenario. So example includes reversing a string. Suppose you want to reverse a string, okay, or a more real life example. Suppose you are implementing an editor like Microsoft Word, okay, or even a PowerPoint program or Excel. Each of these programs, they normally allow you to undo. Okay, so basically what they do is they use a stack to keep track of the commands that you have executed. So anytime you click the undo operation, they will check the stack to see what was the last operation that you did, and then they will undo that operation for you. So you can imagine the usefulness of stack in this situation. Another real life example is the back button, on your browser. So you open your browser, you visited many websites, and suddenly you decided that you want to go back to the previous site. You just click the back button and it will take you there. How does it do it? Again, it makes use of stack. Each link you go to, it will put it in the stack. Click to go to another link, it will put that in the stack. So anytime you click the back button, it will check the stack and see which site was visited last, and it will remove it and then go to that site for you. This is the idea. Okay, we're going to take some real examples and also write Java code to show how stack is used. Starting with the simple case, reversing a string of characters. Okay, so the user enters a string, say salam, and he wishes that string to be printed in reverse order. How can we do that with a stack? This is an example. Okay, so we have a program here called reverse. As you can see, it is receiving a string as an input. And the first thing we do here is we create a stack of character. LL stack, if you remember, is our own implementation of stack using linked list. So create LL stack of character. Okay, call it stack or any name you like, and initialize it with a new stack. So a new LL stack. Okay, so all you have to do actually is push all of the characters of your string S into the stack. So for example, if the user enters salam, just go through the characters of salam one by one and push them in the stack. So S will be pushed first, then A, then L, then A, M. So M is the last one to be pushed. Okay, this is what this loop is doing. Say for I from 0 until the length of the S. Okay, get the character at I, so get the character at 0 initially and push it in the stack. Stack.push, character at 0. Stack.push, character at 1. Stack.push, character at 2, and so on. So at the end of this loop, we will have pushed the characters in our string S in the stack. Okay, now to get them in reverse, just you need to be calling pop, because pop will remove the top element first. Okay, and then pop the A, and then pop the L, and so on. So here what we do is we start by initializing an empty string, and then we do another loop for I from 0 to the length of the original string, pop a character from the stack, so it's going to be M, add it to the empty string, so it will, so the string result will have now only M. Okay, then pop the next top character, which is A, and append it to the result, and so on and so forth. So by the end of the loop, we will have all the characters pop out and appended to result. Just return the result. Okay, this here shows you the sample output when this program is run with salam as the input. Say enter the string to reverse, the user enters salam, and the program says the string reverse is malas. Okay, so this is the idea. So this is a very straightforward example of application of stack. Let's take another more interesting example. Stack can be used to check for matching delimiters. As you know, in Java there are many characters that come in pair. For example, the parenthesis, left parenthesis is always followed by the right parenthesis. Similarly, square bracket, like the one we use to create an array, is always followed by a closing bracket. And opening braces, like the one we use at the beginning of a block, like a beginning of class or beginning of method, is always followed by a closing braces. Okay, and we also have things like comments. So comment will start with slash star and end with star slash. You can also have a string, which is usually in double quotes. So all these are called delimiters. So now one application of stack is to receive a Java code or just a Java statement. It could be one line, it could be a whole file, and to check whether that code or that statement has matching delimiters. I'm sure you must have seen it in your Java programming. The compiler will stop after you attempt to run your program and tell you missing a closing bracket or missing braces and so on. This is actually how the compiler is doing it, okay, by applying a stack. So here, this is the idea. We're going to go through the input code or input statement. Anytime we see a left pair, we push it in the stack. Okay, if we meet a right pair, we pop the one in the stack. Okay, and we continue doing that. Now there are two conditions for the input string to be valid. One is that we should never encounter a right parenthesis or a right pair while the stack is empty. Okay, the stack should not be empty. It should contain the left one. Okay, and the second condition is by the time you finish processing your input string, the stack should be empty. Because remember, each time you encounter the right one, you're going to remove the one in the stack. Okay, and so on. So the stack should be empty at the end. So this is the idea. These are some examples just to show you before we look at the code. This is obviously a valid expression because this will make us to push, this will make us to pop. Push and pop. At the end, the stack is empty, and therefore the expression is valid. It has matching delimiters. This is also valid. Push, pop, push, push, pop, pop, push, pop. So clearly there is no issue here. And similarly here, push, 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 pop. Okay, so it will pop this one, and then pop will pop this one, pop will pop this one, push, okay, push, pop, and pop. Okay, so there is matching pair in this one as well. However, this set of examples do not have matching delimiters. As you can see here, this is push, pop, push, pop. And now we are supposed to pop, but the stack is empty because this right doesn't have corresponding left, and therefore this will be invalid. Okay, similarly this is invalid. Let's see, push, pop, push, push, pop, pop. Again, here we have a right parenthesis, but there is no left to pop, so this is obviously not valid. Okay, similarly here, push, 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 pop. Now this is very important. Here is a pop. The stack is not empty, but the top of the stack doesn't match this right. This is a bracket, square bracket, but this is a normal parenthesis, so there is an issue. Okay, so this is an application of stack. It is used by compilers actually to check whether your code has matching delimiters. Okay, let us look at the algorithm for this before we look at the Java code. This is the algorithm from the book. So we're going to receive the input, usually a file containing your Java code, and you're going to read that file character by character. Okay, so first read the first character before starting the loop. Read the first character and save it in this variable ch. Now start a loop. While not end of file, so as long as we have not reached the end of file, check if the character that we just read before the loop starts, if it is any of the opening brackets, just push it in the stack. Okay, else if it is a double quote, then we know we have a string, so skip all characters until you encounter a double quote. Okay, else if it is any of the right parentheses, so here you have to actually compare the right character that you just read against the one you're going to pop from the stack. Okay, so you check if you are ch, which is one of the right parentheses, and the one you pop from the stack, if they do not match, then you have to return an error immediately. If they match, you're just going to continue and read the next one and start the loop all over again. Okay, but so the issue here is if they don't match, there is no need to continue. You can return a false immediately. Okay, the other delimiter you may encounter is the comment. So if you encounter a slash, you have to be careful. Slash is also used for division, so you have to read the next character. Is it a star? Okay, so we have a slash star. In that case, keep all characters until we meet the corresponding star slash. Okay, you should report an error if you reach the end of file without finding the corresponding star slash. Okay, now in case it is not a star, so this is a normal slash that is used for division, therefore don't return an error. Simply read the next character and start the loop all over again. This continue means start the loop all over. Okay, right. Now if the character you read is none of this, just ignore it and read the next character. Okay, so read the next character and start the loop again with this new character. Okay, so this is actually the end of the loop. This if statement is not part of the loop. Okay, the loop finishes here. So now at the end of the loop, the stack must be empty, because if it is not, there is an issue with your file or with your statement. So we have a statement here that says if stack is empty, success means return true, else return false. Okay, so this is the algorithm. Let us see the implementation of it as a Java code. It's much easier actually than the algorithm. So this is the method. We're going to see this in the lab as an example. Delimiter matching. It receives a string S and it creates a stack of character. Okay, we have a variable ch, and then we are using a for loop, not necessarily a while loop. Just go through all the characters in S. So for I from 0 to the length of S, get the character at I and save it in ch. So now we check if ch is any of the opening brackets. If it is this or that or that, just push it in the stack. Okay, else if it is any of the closing brackets. So actually this program is only taking care of the brackets, doesn't worry about the comments, doesn't worry about the string. Okay, if it is any of the closing brackets, then we know that we should not encounter a closing bracket while the stack is empty. So the first thing to check is if the stack is empty at this point, then return false immediately, because you cannot have a closing bracket while the stack is empty. Okay, else, so meaning the stack is not empty. So the next question is, this closing bracket, does it match the opening bracket in the stack? Okay, so we have a method here, matching bracket, which will compare stack.pop, so this is the left version, against your ch. Ch is the right version. Okay, if they do not match, immediately return false. But if they match, you cannot conclude yet. We have to go and get the next character and repeat. Okay, now this matching brackets is actually a separate small method. Let's go over it. Okay, matching bracket is a Boolean method that is supposed to take two characters, ch1 and ch2. Okay, and you can see it is returning true if ch1 is this type of left parenthesis and ch2 is this type of closing parenthesis, or ch1 is this and ch2 is this, or ch1 is this and ch2 is this. So in any of these cases, we're going to return true, otherwise we return false. So this is how our method here will check if the left and the right, if they match. If they do not match, return false. If they do match, then everything is still good, but we cannot immediately return true until we finish the string. So go and get the next character and repeat the process. Okay, so this is the end of that for loop. At the end of the for loop, as we saw in the algorithm, we now have to check what is the status of our stack. If it is empty, we shall return true. The delimiters are matching in this string. Otherwise, return false. Okay, so this is the example for checking for matching delimiters using a stack. This is showing you, according to the figure we have in the book, figure 4.2, how this program will actually work. Okay, so this is the expression we want to check whether it is having matching pairs. Okay, this is our stack. We will see the status, and this column will contain the current character. Okay, so first we're going to get S. This is the first character. Okay, obviously S is not one of the characters we are concerned with. We are only concerned with the brackets. Is this type of bracket or this type of bracket or braces. Okay, so we just ignore it and get the next one, which is equal. Again, ignore the equal, ignore the T, ignore the now. When we read this bracket, it is an opening bracket. Therefore, according to our program, we should push it in our stack. So you can see the stack is no longer empty. Okay, it has an opening bracket. Okay, we read 5, ignore the 5, it's not a bracket. But when we read this one, it is a closing bracket. So the first thing to check, is the stack empty? No, it is not empty, which is good. Second one is this right matching this left? Yes, it is matching this left. So continue, don't stop, don't return true yet, but there is no issue. But if, of course, the stack is empty or they do not match, we have to stop immediately and return false. Okay, so this is what you see here. When we encounter this, we just pop this one, and our stack is now back to empty. Ignore the plus, ignore the U, ignore the slash. But now, when we read next, it is an opening left parenthesis, so we have to push it in the stack, which is what you are seeing here. Okay, ignore the V, ignore the times, but now we have another opening bracket, so we're going to push it in the stack. So the stack now will have 2 brackets. Okay, 2 brackets. Good. Ignore the W, ignore the plus, ignore the Y. Now, when you meet this closing bracket, the stack is not empty, and also the top bracket here matches this one. So just pop it and continue. Okay, finally we encounter this one. It is again, we will check the stack is not empty and the 2 are matching, so we're just going to pop this one, so the stack will be empty now. Okay, and we're going to continue. Finally, we meet the semicolon. We're going to ignore the semicolon. Now at this point, we have reached the end of our string and our stack is empty. Therefore, the conclusion is the expression is valid. Okay, this is the idea of this example. Another example from the book is called adding large numbers, large integer values. So the idea here is, as we all know, computers' memory is fixed, and therefore there is a range. There is a maximum value that you can store in terms of integer. You don't say the integers are from -infinity to infinity like we have in mathematics. Okay, so you have very large integers. Obviously you cannot save them as integer type, because integer type has a fixed limit. If your number is more than that limit, then you cannot save it as an integer. But you have another option. You can save it as a string, because string can be of any length. Okay, so just save it as a string. But then there is a problem. If you save it as a string, then you can no longer use addition, subtraction, and so on to manipulate these numbers. This is what this problem is about, or this example is about. The example is to show you how to add numbers even though they are represented as a string. Okay, yeah. So this is the algorithm from the book. Basically, it's going to use 3 stacks. The first stack is going to be used to store all the numerals or all the digits of the first number. Okay, so read all the digits of your first large number, push them in the stack. Do the same for the second number. Read the numerals of the second number and store them in the corresponding stack. Okay, so we have 2 stacks with the 2 numbers. Now, initialize a variable result to 0 and then start a loop. And the loop says, while at least one of the stack is not empty. You're going to pop 2 numbers from both stacks. So pop a number from each of the non-empty stack, add them to result. Okay, result initially is 0, so just add the first number you pop from stack 1 to the result, and also add the second number to result. Okay, so you have a number in result. Now, well, it could be 1 digit or 2 digits. Either way, you're going to push the unit part. Okay, push the unit part in the result stack. I'm going to show you an example in a moment, so this will be clear once we see the example. And the tens part, you're going to use it as a carry. So store the carry in the result and then repeat the process. Okay, so this process will continue. Now you're going to pop another 2 numbers from the 2 stacks, add them to result, put the unit part in the result stack. Okay, so this is stack number 3, the one carrying the result. This is where we'll be pushing the unit part. Okay, and then store the carry back in result and repeat. At the end of the loop, check if your result is not 0. You have to push it in the stack, in the result stack, yani. So it's a push the carry on the result stack if it is not 0. Okay, so at this time we have finished. To get our result of the addition, just you need to pop the characters in the result stack. Okay, so this is what this last statement says. Pop the numbers from the result stack and display them as your output. To make this example clearer, we have a demonstration figure here from the book again. So although the example is supposed to show how to add large numbers, this example is going to use very small numbers just to show you how it works. So assuming we are trying to add a number 592 plus 3784. Okay, these are the 2 numbers we wish to add. So the first thing to do is push the digits of the first number in stack number 1. So you can see 592. Push the digits of the second number in stack number 2. So you can see 3784. And create another empty stack. This will be used for the result. Okay. Define a variable result, initialize it to 0, and then start a loop. So the loop will be popping a number each from the non-empty stacks, add them to result. Okay, so here we're going to pop 2 and pop 4. Result initially is 0, so the total if you add, you're going to get 6. Okay, now 6 is only one number, so it is the unit part. There is no tens part. So all you have to do here is push this unit part in the result stack and then repeat the process. Okay, so next we're gonna pop 9 and 8. 9 and 8, add them up, you see that we have 17. So this time we have a unit part and we have a tens part. Push the unit part in the result stack. So 7 will go to the result stack. But the tens part, which is 1, we're going to put it in result, which will be used for the next operation. So 1 is going to be added to the next pair that we're going to pop. Okay, good. So next we're going to pop 5 and 7, add them up along with the carry from the last operation. So we're going to have 1 plus 5 plus 7. Okay, this will give you 13. Push the unit part in the result stack. So 3 will go to the result stack. The tens part is going to be used as the carry for the next operation. Okay, now this time one of the stack is empty, so there is nothing to get from there. We only need to pop the 3 from the second stack, add it to the carry. So we're going to have 1 plus 3, which is 4. Okay, so 4 only has a unit part, push it in the stack. Okay, now at this point both the two stacks are empty. Now here is another important point which is not shown by this example. If your two stacks become empty, you have to check the carry. If it is not 0, you have to push it also in the stack. You don't just throw it away. In this case we don't have any carry, so there is no issue. We have reached the end of the loop. Therefore, to get our answer, we just need to pop out these values from the stack. So if you pop out 4, 3, 7, and 6, this is what you're going to have. So you can see that this process will actually allow you to add these two numbers correctly. And this will work whether the numbers are small, as in this example, or they are 100 digits each, or more than that. The addition will always work. This is the idea of the example, using stack to add large integer numbers. Okay, this is the Java code for the example. Again, we're going to see this code in the lab. So it receives 2 integers but as strings, string n1, string n2. It creates 3 stacks of integers, so stack 1, stack 2, stack 3. Okay, the first loop here goes through the characters of n1 and convert them to integers. Please note, this is not a stack of characters, it's a stack of integer. So when you get the character from this string, you have to convert it to a number. You have two options: either you use a pass int, or in fact there is a method from the character class. It is called get numeric value. So if you say character.get numeric value and you give it the character, provided that character is actually a digit, it will convert that character to a number. You see, this int n is an integer. So get the numeric value of the character at I and save it in n. Now push that n into the stack. Okay, so this loop will push the digits of the characters, of the numbers, the digits of the first number in the stack number 1. This loop is similar. It will push the digits of the second number in stack number 2. Okay, now before we start our loop that will do the addition, we initialize 3 variables: result to 0, and then ns1 to 0, ns2 to 0. Okay, Now we start the loop. The loop will continue as long as at least one of the stacks number 1 and stack number 2 is not empty. So it says while not stack 1 dot is empty or not stack 2 is empty, repeat. So if stack 1 is not empty, we're going to pop from it and save in a variable ns1. So now you can see why we define those two variables, ns1 and ns2. Similarly, if stack 2 is not empty, pop from it and save in ns2. Now add the three variables, results, which initially is 0, plus ns1 plus ns2, add them all to result. Good. So we have a number here which may be only 1 digit or 2 digits. The question is, how do we get the unit part from this number? Very easy. Just you need to do remainder. Result remainder 10. For example, if you have 17 remainder 10 will give you 7, right? That's the idea. So remainder operator is very important here. It will give you the unit part of this number. Okay, so that unit part, push it in stack number 3. Stack number 3 is the result stack. Okay, good. How do you get the tens part? The tens part, you get it by doing slash result slash 10. For example, 17 slash 10 will give you 1. Okay, so that 1, save it in result. It's going to be your carry, which you will use for the next operation. Okay, but before you repeat the loop, reset ns1 and ns2 back to 0. The reason why this is important is because in case one of the stack is empty, then we may not have a chance to update the numbers here. So we may be using a previous number for the next operation. So to avoid that, before you begin the loop again, just reset them back both to 0. They're going to be reinitialized anyway by popping from the stack. Okay, good. So this is basically the loop. At the end, before you start popping your result, you have to check what is in result. If it is not 0, you have to also push it in the result stack. And then finally, to get your result, initialize a variable answer of type string to empty, and you keep popping from stack 3 and appending to this answer. So while stack 3 is not empty, stack 3.pop and append it to answer, and so on. At the end of the loop, return answer.